Assalamualaikum and good evening to Dr. Anwar. My name is Muhammad Rashdan from Group 5 and this is my team member Muhammad Ishaq bin Abdul Hamid, Muhammad Syaril bin Baharudin, Muhammad Zakon bin Hasni and Muhammad Shazlan bin Rozaini. Today we want to present about evaporator heat exchanger. Okay, for my part of introduction thermodynamic is a part of physics that deals with studying energy and its change in different systems. It helps understand how materials and systems behave based on temperature, pressure, volume, and energy. The design and improvement of energy system, engine, heat exchangers, and industrial process rely on thermodynamic laws. For example, system and surrounding, state variable, laws of thermodynamic processes, and heat and work. Okay, for the first one, system and surroundings. A specific part of the physical universe under study is called a thermodynamic system. The surroundings include everything outside the system that can exchange matter, energy, or work with the system. Okay, for number two, state variable. The state of a system is determined by its thermodynamic properties, also known as state variable. Some examples of these variables include temperature, pressure, volume, and internal energy. The system overall behavior is influenced by these characteristics. And number three, law of thermodynamics. Law of thermodynamics define physical quantities like temperature, energy, and entropy in thermodynamic system at equilibrium. There are three fundamental laws of thermodynamics: the first law, the second law, and the third law. Okay, for number four, thermodynamic processes. When a system changes states, thermodynamic processes describe the change. Some common types of processes include isothermal, constant temperature, adiabatic, no heat transfer, isobaric, constant pressure, and isochoric, constant volume processes. And the last one is heat and work. Thermal energy transfer due to temperature difference is called heat, which means the symbol is Q, while energy transfer related to force and displacement is called work, which means the symbol is W. Both heat and work can change a system condition. Background and theory about thermodynamics. Thermodynamics focus on the properties and processes of systems, explaining their traits and change. Temperature, pressure, volume, internal energy, entropy, and enthalpy outline the key processes and properties. Definition and the characteristic. A heat exchanger is a system used to transfer heat between a source and a working fluid. Heat exchangers are used in both cooling and heating processes. The fluid may be separated by a solid wall to prevent mixing, or they may be in direct contact. Okay, for the principle of thermodynamic and energy conversion. These fundamental ideas of thermodynamic and energy conversion are necessary to comprehend and interpret the behavior of energy in various systems. The guiding principle clarify the limits and possible use of energy usage, aid in determining the feasibility and effectiveness of energy conversion processes, and provide direction for the design, analysis, and optimization of energy system.
My name is Muhammad Ishaq bin Abdul Hamid, CD 220008. So my part is selector steady flow device SSFD. A thermal exchanger primary purpose is to facilitate the exchange of heat between two mediums. Essentially, it serves as a passage for one medium to flow through it while the other medium passes around it on the exterior. They have the heat transfer mechanism. For the first one is convective thermal transfer to the inner surface of the pipe. Second, conductive thermal transfer across the pipe wall. And lastly, convective thermal transfer from the outer surface to the outside medium. Heat exchangers are categorized based on how fluids move and the type of construction. They have two types of construction. For the first one is parallel flow and second is counterflow. For parallel flow setup in which hot and cold fluids enter at the same end, flow in the same direction and exit at the same end. For counterflow, a counterflow configuration in which fluids enter at opposing end, flow in opposite direction and exit at opposite end. The fluid in tubes varies in both arrangement depending on whether in unmixed or mixed. The fluid is considered to be unmixed because the fins restrict motion in the direction x and y that is transverse to the main flow direction x. Second one is feasible in the transverse direction for the unfilled tube bundle and temperature fluctuation are largely in the main flow direction. From this slide, we use formula which is heat transfer rate per unit length and to define an overall heat transfer coefficient H0 per unit length. From equation 1 and equation 2, the overall heat transfer coefficient H0. Application of the SSFD. A heat exchanger is a device that transfers heat between different fluids or surfaces. Heat exchangers are important for many applications that involve energy conversion or transfer. There are different types of heat exchanger based on their design and function. Classification of heat exchanger. For the first one is shell and tube heat exchanger. Shell and tube heat exchanger have a tubular tank and tubes for heat transfer in parallel or opposite directions. They are used in various industries as evaporators and condensers and can be mounted vertically or horizontally. They need to be well attached and made of suitable materials for the environment. Advantage of shell and tube heat exchanger. First one is internal reliability. Shell and tube heat exchangers resist scaling and need less cleaning. Second, power regulation. Number of section, pipe size, and power can be adjusted. And lastly, long service life. Shell and tube heat exchangers last longer. Disadvantage of shell and tube heat exchangers. First one is large size. Heat exchangers may not fit in some facilities. Second, outer case vulnerability. Tube heat exchangers leak and corrode over time. And lastly, efficiency. Heat exchanger lost 30% of energy.